with today's class. Welcome to class number 6 of Java Level 2. And I want to pick off right where we left off, talking about Java classes. So last week, we started the introduction to the concept. And I said, this whole idea of classes, objects, is really going to carry us through most of the remaining classes of Java 2. So I hope you're excited to learn more about this topic. Let me start with my screen share and some review questions. Last week, I discussed what classes are. They're kind of like a blueprint of creating objects. And I said that very simply, classes consist of two different sections. You have your methods and you have your fields. So the methods are basically just what we talked about in Java 2, little bits of code in a chunk that does some sort of computation or process, right? It's a mini sub process. Does anyone remember what fields were in terms of a class? Like, what's the purpose of them? Why do we have them in the class? As maybe some examples of fields in classes. Like last week, we worked with a car class. So does anyone remember like some examples of fields that we had of that car class? As always, feel free to just message in chat or to unmute and speak up. Good afternoon, Christopher. Hope you're doing well.
Yeah, I'm doing well. How about you?
It's good. Pretty typical afternoon for me. Does anyone want to answer this question? Maybe as a hint, I can answer the first part. What is like the purpose or why do we have fields in classes? And then maybe I can have a couple of people give me examples for the car class. So the purpose of fields, or really what they are, they're just variables. They store information. They store bits of data for the class. So very simply, like I said, a class has fields and methods. The fields are just what it knows, what it stores. And then the methods are what the class does, right? So very simply, fields are just variables, right? They just are bits of information. In terms of the car class that we were working with last week, we had a couple fields. Does anyone remember some of the ones that we had, or maybe just some new ones that could be there, that you could imagine being in a car class? So I think we had two fields from last week's car class, and they were the brand stored as a string. So this would be like Toyota or Honda or BMW, whatever, as a string. That's one field of the car class. And then we also had another field, which was the speed of the car stored as a double, right? So does anyone, can anyone give me other potential fields that we could add to the car class? Both like what it, oh, I'm sorry, Christopher?
Maybe fuel to say how much fuel the car has left.
Yeah, and what kind of data type would that be?
I think fuel will be double.
Yeah, I agree. A double would be a great way to store it. Maybe you could do int, but then you don't have the precision of decimal values. Great. Anyone else want to give some possible fields of the car class? How about Stephen? Can you help me with one field that we could add to the car class, as well as the data type it would be?
you ask the question again?
Yeah, no problem. The question was, what is a field that I could add to our car class from last week? So our car class already had the brand stored as a string. I already had the speed stored as a double. And Christopher says we could add the fuel in the tank as a double as well. So can you come up with another field that we could add to this car class?
The amount of miles it is driven as an integer.
Yeah, that'd be great. So like cars typically have a odometer, and that could be a field. It's just a bit of information that the class would store or the object would store as well. So again, that's what fields are. It's just a fancy name for a variable. Like that's the easiest way to think about it. The second review question is something that we talked about last week and is kind of, well, I don't want to spoil it, but it's kind of a bridge between classes and objects. But we had this special thing called a constructor. And does anyone remember what the constructor does in a class? Like, what's the purpose of it? Why do classes have constructors? The name of this thing, constructor, should be a hint at what it does. So as a hint, perhaps, the constructor is just a method. It's a special method. It's a little bit different than the other methods that we've seen so far. But at the end of the day, it just looks like a method, right? It takes in parameters and it does stuff inside. Devin, I think your mic got unmuted. Thank you. So let me go here. So this is the car class. I added some things to this class between last week and today, but on my screen here, one of these methods is the constructor. Can anyone tell me, point out which one of these is the constructor to me? And you could do like 1, 2, 3, 4, 5. There's 5 methods on the screen. Which one of these is the constructor? Let me, if I don't get any answers in chat or hear anyone, I will start calling on people. How about David? Can you help me with this? Which one of these methods on the screen is the constructor for the car class?
The public one at the top, car, string B, string C.
Yep, thank you very much. This is the constructor of the class. There's a couple ways that this is different and that points out that this is the constructor. So the most simple one is that the name of the method is the same as the name of the class. That's required for the constructor. You can't call the constructor whatever you want. It has to be called the name of the class, right? So if you have a class dog, the constructor will be called dog. If you have a class, I don't know, house, the constructor for that has to be house. It has to be exactly the name of the class. Can't be any different. It can't even have different capitalization. It has to be exactly the same as the name of the class, right? So that's one way that points out this method is the constructor. There's another way that you can see that this is a constructor, or at least that it's a little bit different than the other methods on the screen. This method, if you look at how it's defined, or at least the header, the first line of the method, it starts out similar. It starts out with public, just like any of the other methods. But notice it jumps straight to the name of the method. It doesn't have a return type. It doesn't even say void, right? So any quote unquote normal method will have the return type between your modifiers, your public, static, whatever, and the method name. There will be the return type in the middle. Constructors, on the other hand, don't have that. Last week I said one way you can think of it is that the return type of the constructor is kind of the class itself, because this brings us to what a constructor does. A constructor creates an object of that class. So I create this car class, but then at some point I want to make specific cars. I want to make a blue car. I want to make a red car, for example. You use the constructor to do that. The constructor constructs, it builds the objects. And specifically, it tells you how to build the objects. So here, if you look at the constructor, it says that it's a method that takes in two strings, string B and string C. And then what does it do? It, in general, creates your fields. It gives values to your fields. In this case, I had 3 fields: speed, brand, and color. And so speed, I just say all cars start at 0 miles per hour. But the brand is the first thing that's passed into the constructor, and the color is the second thing that's passed in. So when I make car objects, I can specify a brand and I can specify a color, and they get stored into the fields. Given this, a follow-up question at this point now is, I have this constructor, right? This is the constructor for my car class. Can someone type into the chat what it would look like to make a car object, right? How do I use this constructor to make a car object? As a hint, it's going to be something equals something else. And I'll give the left-hand side because that's not the interesting part. It's going to be like car C equals something. I put it into chat. This is how you make a car. I want to know what that ... should be. How do I use the constructor? And if you know, please type it into the chat and just send it out to the global chat for everyone to see. New constructor method. So that's great, Andrew. We do need that new keyword. I wonder if you or someone else could be a little bit more specific. So what should that constructor method be in our case? Like, I have a specific constructor here. I want you to use this constructor. So very, very close. New car. I'm a little bit hesitant on what's inside those parentheses. Like, what is B and C? Right. Okay, yeah, so I think you got it pretty much. So let me just reveal the answer. It's basically what you said. So you have car C on the left-hand side. And then the way you use the constructor is you say new, because we're creating a new thing. We're creating a new object. And then you have the name of the constructor, because it's just a method. Whenever you use a method, you have to call it by the name. That's what the name is for. So the name of the constructor, if you remember, is the same as the class. It's car. And then we just saw that the constructor takes in 2 things, a string B and a string C. And so we have to provide specific values. I was asking what B and C were. You have to give specific values here. So for example, let me just change the capitalization. I'm going to create a car with brand Tesla and color blue. Notice I have to give like real strings here. like real things with quotes. I can't just say A or B or like B or C unless above I said like string B equals Tesla. Then I could put B here. But in general, you need to pass real values here. Like you have to fill in the blanks at this point. So with this, you create the car object. And again, we create this car object so that later we can use these methods. We can use the break, drive, this other drive method, and a public string description method. And so these two are methods that I added that were new from last week. So I want to go over this quickly, and this introduces us to the new content for this week. But let's look at the second one really quickly. It's a very simple method. Notice it's a public method. Public, we saw this last week. Public tells you where or who has access to this method. When you say a method is public, that means anyone can access this. Whether you're in the car class, whether you're outside the car class, whether you're in the same folder, in the same package, or somewhere completely elsewhere, anyone can access a public method. If I made this a private method, that means only the car class, only inside this car class can we call this method. If it was private, we wouldn't be able to call description here. Notice immediately once I change this to private, once I change this method to private, immediately this becomes an error because we're no longer in the car class here. We're in this runner class. This is not the car class. This is something else. So we don't have access because it's private. Even though we're using a car object, it doesn't matter. You have to be in the class, not the object, the class. And so let me just make this back to public. And you can see immediately after I make this public, the errors go away, right? Because now I have access again. It's kind of like a gatekeeper. It tells you who has membership, who is able to look at this and use it. So it's a public method. It returns a string and it's called description. And what it does is it just returns a string that describes this car. So I make this string and this is a, whatever the color is, whatever the brand it is, driving at whatever the speed it is, right? So here, I make a new car, I tell it to drive, and then I print out the description. And then this stuff is new, so we don't have to worry about it. But let's just look at these first 3 lines of code. We run, and if we wait a couple seconds, you can see at the bottom, it prints out the description. This is a blue Tesla driving at 60 miles per hour. That's because this drive sets the speed to 60. Right. So this should be not too exciting or too interesting, but it is just an example of another method of the car class. The second method that I added is this one. And I have a note here, method overloading. This is kind of a throwback, but does anyone want to tell me what method overloading is? Like, what does it mean that this is an overloaded method? This is probably, like 3 weeks old, I think. As a hint, it's related to this one. If I didn't have this method, it would not be method overloading, right? It's because I have both of these that it's method overloading. So does anyone remember kind of the definition of like what an overloaded method is? When is a method overloaded? It has the same something as another method, but different
Signature.
something. Yeah, so
Signature.
so it's the same name, but different parameter list.
Oh,
And so
name.
Yeah, so the terminology is a little bit weird. So I'm not gonna pick that much. The signature actually does include the parameter list, so it's not the same signature. It's just the name is the same. So notice the name of these two are both drive. But this one takes in no parameters, and this one takes in a single one. And so this is method overloading because it's the same name, different parameter list. Another way to think about it is you're kind of giving this method more functionality. You can call drive with no parameters. You can also call drive with one parameter, and it will do different things depending on how you use it. And so this is overloading because you're giving like a bunch of, well, you can do this as much as you want. You can make a drive that takes in 2 parameters. I don't know what it'd do, but you could do that. It is just giving more and more functionality on it. You're loading more functionality to this method, and it's called overloading because of that. Andrew says, can you make an array of objects? Of course you can. So if we go back to this class, it's a great question. Our custom objects, like this car object that we created, the car class, there's nothing special to it. It's just like any other class or object that we've been working with. So we can make an array of strings. So we can make an array of cars, right? Let me make a car array, right? I can say it's a car, it's an array, right? And I'll just say ARR. Let me actually make 2 cars. C and C2, and this will be a red Tesla. So you can make 2 cars, and you can do this. I think like this, and I can say like system.out.println ARR0 dot description and system.out.println ARR1 dot description. And if I finished up, all the errors go away. And if I run this, let me get rid of this print statement. If I run this, you can see that it prints out, this is a blue Tesla driving at 60 miles per hour, and this is a red Tesla driving at 0 miles per hour. And that's because that's the 2 cars I have. And I'm printing out the descriptions of each. Yeah. So again, even though this is a class that we made ourselves, treat it just like any other class that exists. Just treat it like a scanner, treat it like a string, treat it like an integer. It's just an object. There's really nothing unique about it other than we wrote it ourselves. So back to here, method overloading. The reason I brought this up here is because later on, we're gonna see something similar to method overloading, and it's called method overriding. So I'm gonna compare these 2 later on. But anyways, this method, it just takes in a number, and instead of setting the speed to 60, like drive with no parameters, instead sets speed to speed plus the change, or whatever it's given. So I can basically control the speed now. Instead of just 0 or 60, I can actually like increase by 10 or decrease by 5, something like that. And I can show it off here. So I can c.drive, let's just say I want to decrease by 30 miles per hour. So I drive -30. And if I print the description out again here and run it, you can see now it's driving at 30 miles per hour. There we go. So this is a basic class. I know the review is going a little bit long, but the last thing I want to talk about, if we remember, I briefly introduced the idea of static versus non-static last week. And I showed what happens when you make one of these fields static. Let's just say the brand be static. Does anyone remember what this does? Like, kind of behind the scenes, what does it mean for a field to be static? How is it different than a non-static field? There's kind of one important difference now between, for example, the speed or the brand and the color. One is static, one is not. How does that impact how it works or how it's used? Alan, do you remember the difference between static fields and non-static fields?
I forgot.
No problem. Definitely static is,
Is it like if static like stays the same? I forgot though.
yeah,
Yeah.
it's related to that for sure. So you can actually think of it like that. Static, you can think of it like static versus dynamic, I guess. Like, although I'd say maybe that makes it more confusing. Anyway, so what the difference is between brand and color now, between static and non-static, is that when you make a field static, it means it's shared across different instances. So here, when we created C and C2, if brand is static, they will share the same brand, right? If you change one, it will change the other. On the other hand, the other fields are non-static, speed and color. That means each instance, C and C2, they're different instances. They will have their own copies of the field. So like they will have their own versions. They will have separate versions. But for static fields, they will have a single shared one. So that means they all have the same one. They always have the same field because it's shared. That's really the important thing about static versus non-static. Another way to think about it is like how many copies of this field exist. If it's a static field, there's a single copy. No matter how many cars you make, there will be a single brand field if you make it static. However, this color field, if you make 10 different cars, you're going to have 10 versions of this field. Each car is going to have its own version, right? So non-static fields or instance, that means the same thing. Non-static and instance mean the same thing. Non-static fields has as many versions as there are instances. That's why it's called instance, actually. But let me just make that back to non-static because the brand should not be static. Each car should have its own brand instead of sharing one. Right. So going through all that was kind of all the basics of classes that we've covered so far. We will be using this moving forward, and we will actually be going back and revisiting some of these concepts. But I do want to take just a couple of minutes to see if anyone has questions about what we covered with the review, talking about classes so far. Fields, methods, constructors, static, non-static, how to work with them. Like once I create this class, how do I use the methods? How do I make an object? Any of this, I'd be happy to go over any of the pieces. right? So this car class is our simple class. Has your fields at the top, has the methods below, and one of them is the specific constructor. The constructor is special because it lets you create the objects. One thing I did not mention, but I should, this car method can be overloaded. You can create multiple constructors. There's nothing stopping you. So for example, I can create a 3-argument constructor. Right? This is called a 2-argument constructor because it takes in 2 arguments. But maybe I want a 3-argument constructor. And maybe this 3-argument constructor takes in the speed as well. So I can say double s. And so instead of setting the speed to 0, I can set the speed to s. And so what this means is now there's 2 ways of making cars. I can either specify the brand and the color, or I can specify the speed, brand, and color. And both of these will create a car object in their own way. Both of them are valid constructors. But that's the class. And then using it, you create an object, and then you use the object to access the methods and access the fields. So I know I didn't go over the homework, and that's just because the homework was a little bit more open-ended. So there's no like solution that you should have done. It really was up to you, like what you made, what class you wrote. And so I posted this car class as an example for you to take a look at. But for people who submitted a response, I either have already responded with comments or I will be. I know I saw a couple came in a little bit late, so I didn't have time before class to look over all of them. But yeah. With that, I want to go over the new material for today, which is kind of the first step above simple classes, the basic classes that we've seen. And what that step is called inheritance. And so this should remind you of like genetics, and it's actually very similar. It's called inheritance for that reason. But inheritance in Java and in programming languages in general means to inherit attributes, which are the fields, as well as methods from one class to another. To put this in a little bit more simpler terms, it means we're lazy. We're making a new class and we want it to have some of the same functionality as one that we already wrote, right? Maybe it's very similar to this other class. It just has a couple new extra features. Instead of copy pasting things all over again, we do inheritance. We inherit those old fields and methods into our new class, and then we can add whatever we want on top of it. It just allows us to stop copy pasting so much. In terms of the terminology here, there's a couple ways that you will see it out in the internet and with other people. The most common is subclass and superclass, or child class and parent class. I will be using both equally, but they're kind of the same. So you have kind of one at the bottom and one at the top. The top one is the parent. It's the original. It's the superclass. It has the stuff that you've already like made or already exists. And then the subclass, the child class, the one that inherits, is the new one that you're making. And it kind of takes the pieces from the old one and brings it in and then adds other stuff as well. Okay. Let's move to the next slide. How this works in Java in terms of coding, we're going to see this shortly, but we use this keyword called extends. And this allows a child class to extend a parent. So extend a parent class into the child class. So you're gonna say extends in the child class, and then you're extending whatever the parent is. So you can say, here, let me go back to Eclipse, go back here. It would be right after the name of the class. So for example, I can say the public class car extends the scanner class. It's gonna have an error because I need to import the scanner class. Oh, let's import, or let me extend the string class. Or can I not? It's final. Yeah, let's go back to scanner. So this is what it looks like. Public class car extends another class. And when you say extends the parent class, what this does is any methods, any fields, anything at all in this parent class essentially gets copy pasted into your new class. So right here now, like, is everything in the scanner class. Right? Everything in the scanner class just gets put in at the top of your class automatically. It's because you say extend scanner. And let me just get rid of the error. Let me just import some random scanner class. Java.util.start. It's still final again. So this is throwing me an error because this scanner class you can't extend, but you would more often use this with classes that you've made yourself. So at this point, we really only have the car class. So I don't have things to extend from, but I'm going to show you another example on the slides in just a little bit. So that's one way to do inheritance. You extend a class. In Java, you can only extend a single class. So you can't extend from multiple. You can't extend scanner and the string class. You can only do one. On the other hand, there's this other thing called implements, and it works very similar to extends, but it's with something called interfaces and something we haven't seen yet. So this is going to be covered in the future weeks, not today. Today, we're going to focus on this extending part of Java. And really quickly, what happens when you say extends? I've already kind of covered this, but more formally, a subclass, the child class, inherits all of the public and protected members of the parent. So no matter where that parent class is, you get access to it. You also have access, well, you also inherit the private fields as well. You just don't have access to them. You don't have direct access, at least. So they are inherited, you just don't have access to them. This also goes into visibilities, but in general, anything that you have access to, you can just use it. Anything that was in the old class, you can use. So in fact, you can use it directly. So that means you can, if the parent class had a field color, now this child class automatically has a field color as well. Members. So here, so this is saying you can use the inherited members as is, replace them, or supplement them new members. Members just means fields and methods. So you inherit both, not only the fields, but also the methods. So the slide just uses that as the combined term. But I do want to point this out. You can use them, you can replace them, or you can hide them. And so these are the most common, using and replacing. You almost never hide. There's almost no reason to do it as well. But if you want to use it, you can use it directly, right? Like I said, if the parent class has a field called color, the child class automatically has a field called color. You can access it, you can set it to something, you can change it, you can do whatever you want directly, right? Just treat it like a variable. You can add members by just declaring new fields, right? So just like how we declare fields here, you can create a child class. Let's actually make a child class really quickly, just so I don't not going through like waving my hands. At the bottom of this, what I'm gonna do is I'm gonna make a new class, and all I say is class. I don't know, like pickup, and this extends the car class. What's this? Yeah, so okay. Don't worry about this too much, but now we have this car pickup class that extends the car class. I need to add a constructor to it. So public, then the name of the constructor has to be the name of the class. So this one's called a pickup truck. And the pickup maybe takes in, it'll just be the same constructor as this, essentially. So this isn't the best way to write the constructor, but this is how I'm gonna write it now. So this is giving me an error because I need to do something like this. So this is kind of an annoying bit. Typically in a class, if you don't define any constructors yourself, one is going to be supplied to you. So every single class has a constructor, whether you write it or not. And the default constructor, what it's called, takes in no arguments. And if you do write your own constructors, then that default one might not exist, right? The default one is only added for you if you don't write any yourself. And sometimes it's important to have this no argument constructor, which is why I was having earlier errors just now. So I just added this, my version of the default constructor. It basically just does nothing. It sets your fields to kind of null values, empty values. And here I make a pickup constructor. And at this point, I can go back to my runner, get rid of all the code that I had so far, and I can make a pickup object now. Maybe pickup p equals new pickup, and my constructor takes in two strings, a brand and a color. I don't know, a RAM, and it's blue. Right, so it's a blue pickup truck. The brand is RAM. And at this point, I can do p.drive. I can do system.out.println p.description because the pickup class extends car. And all of these things, drive, description, these are methods in the car class. And we inherited them. We get them for free. Even though, like, let's look at this car class, pickup class. There's like no, it's almost empty. There's barely anything I wrote in here. But because we said extends car, we essentially copy pasted all of this stuff into this class. Notice even we didn't have to define the speed, brand, color fields in here, right? That's because we defined it in the car class, right? We defined it in the car class, so we inherit it. We get it for free. We get it for free when we say extends car. And so at this point, we can do everything that the car class can do. But maybe I want to add another method. I can do like public void honk, and all it does is prints out. The word honk. And at this point, let me save my file. Let me go back to the runner class. And now I can do p.honk. Yep. Okay, Andrea, I'll get back to you really quickly. That is, I think I know what's going on. But here, notice I just added another method to my pickup class, and now I can use it with my object P. If I go back to the car class, car C equals new car, whatever, I cannot do c.honk, right? That's because this honk method that I just wrote is only in the pickup class, right? So this inheritance relationship only goes one way. Pickup gets everything for free from the car class, but the car class does not get anything in the pickup class. It's one way. The inheritance only goes down. It does not go back up. And so this is kind of why we use inheritance. It makes things easier so that we don't have to repeat ourselves. We don't have to write the same code multiple times. And we can very easily add on new stuff, new functionality. We can change the functionality, whatever you want. It just makes it a lot easier than repeating yourself by copy pasting. So Andrew, you say, when I do this, it needs to be defined in its own file. So you can, I define this in the same file, but you can define it in a different file. And that might be a better way. But I was lazy, so the way you define multiple classes in the same file is that you don't have public in front of it. So notice here I say public class car. This one I only say class, no public in front of it. If I put public in front of this, then I'm going to get errors. And it says the public type pickup must be defined in its own file. The reason for this very simply is you can only have one public class in a Java file. And so to get around it, we just don't make it public. For the most part, for what we're doing, it doesn't really matter if the class is public or not, because everything that we're writing is all in the same package, in the same folder. So when something is not public, it becomes package private, or it has package visibility. Anything in the same package is able to see it, is able to use it, whatever. And so even though this class is not public, this runner class can still use it because they're in the same package. If you wanted this to be a public class though, you would have to make it in its own file. One thing that we've already covered, but just want to make it clear again, whatever class that is public has to be the name of the file. So this one, this file is called car.java, and my public class is car. I can't make this one non-public and make pickup public. It's gonna cause problems. It says, well, it's still, the error message is still the same, but at this point, it's because it's called car.java. You have to have a public class car. So the name of the file must be the name of the public class. And you can only have one. All right. Inheritance, going back to the slides. You can hide certain things by declaring overlapping fields and or methods. The methods has a little bit of an asterisk because a little bit of warning. But if you define a field in the subclass with the exact same name as in the parent class, you kind of hide the parent field. It's because Java prefers to be as specific as it can be. And so if a child class and the parent class have a field called the exact same thing, it will prefer the child class's version. It will prefer the more specific one. And there are ways to still access the parent one, but in general, by default, it will access the more specific, the child version. And so this is what it means to hide the field. You basically create like a new front to it and only work with the new one. The old one still exists, but it's just in the back and no one touches it. In terms of methods, just like fields, inherited methods you can directly use. Any method that was in the parent class, you can now use in the child class. Any method that the parent knows, the child also knows. Very simple. You can hide methods by creating a method with the same signature if it's static. So if you can hide static methods. You cannot hide non-static methods. In fact, this is the new thing that I was talking about, overriding methods, is when you have a method in a child class that has the same name, same parameter list. So same signature even. Both name and parameter list are the same in child and parent. That's called method overriding. It's overriding because you're basically saying, here's a new version of this old method. Don't use the old one anymore. Forget about it. I've paved it over. I've paved it over with this new version and use this one instead. That's what method overriding means. So I'm gonna override one of the methods that I have. I'm gonna override this description method because right now it's talking about, well, it's not talking about pickups. I wanna add something that this is a pickup truck. And so I'm going to override this method by basically copy pasting it into my subclass, my child class. And so here, I'm gonna have a description method in my child class, right? Notice it's the exact same definition. Public string description, no parameters. Public string description, no parameters. They're the exact same. They have to be the exact same. And then in terms of what this method actually does, I'm just gonna say this is a color brand. And then here I'm gonna insert pickup truck driving at whatever and return that. So now if I run my code right here, let me get rid of the offending line. Notice now, when I call description on my pickup truck versus calling description on my car, I'm now gonna get two different behaviors. The first one, the pickup truck is gonna say, this is a blue Ram pickup truck driving at 60 miles per hour. And then this one, well, it's a little bit weird because it doesn't have a brand or color. Let me just make the Tesla again. And then the second one is gonna say, this is a blue Tesla driving at 0 miles per hour, right? Notice this one says pickup, this one does not. That's because I've overridden the method. Instead of using the one from the parent class, it exists, it's still there. I'm just saying, hey, I have this new, better version specifically for this child class. And so you should use this instead. And that's what's happening here. Even though it looks like I'm calling the same thing, p.description, c.description, they're doing two different things. Right? Notice this is method overriding. Can anyone summarize really quickly the difference between method overriding here and method overloading, which we talked about in review? Kind of what's the similarity, what's the difference between the two? In both cases, something is the same. And in both cases, there's something like different, because you can't have exactly the same thing. You can't have identical copies, because then Java will be confused and it won't know how to use which one, right? So in both, there's a way to tell Java which one to use over the other. But they're definitely different. Method overloading and method overriding, they're different. How about this? Let's go with Devin. Can you tell me, when we're doing method overloading, what you see right here, what is kept the same and what is not the same? Oh, yeah, sorry about that. I think I paused it. So I've unpaused it. I've highlighted the method overloading on the screen. I have two methods, and this is an example of method overloading. So it's method overloading because something's the same between these two methods, and there's something that's different. So what's the same? What's different? And a hint, you can ignore what. So the difference, this line is different, 33 and 37, they're different. But the thing to focus on is not what's inside the method, but how the methods are defined. So let me actually shrink them. So here, so comparing these two, how they're defined, how they're described. What's the same? What's different? In terms of the method signature, the signatures of these methods are not the same. So here, no problem. So here, what's the same is the method name. The method name is the same. They're both called drive. What's different is they have different parameter lists. One has no inputs, one has a single input, right? That's method overloading. Same name, different parameter list. So they're called the same thing. When you're using the method, you're calling the same name, but how Java knows which one to use depends on how many inputs you gave it when you called the method. If you called the method and gave in one input, Java knows to use this one, the second one. If you called the method and you didn't give anything, Java knows, hey, I should use the first version. So there's no kind of confusion to Java. It knows exactly which one to use, even though they're called the same thing. On the other hand, when we do method overriding, there's more similarity now. Not only is the name the same, right? So when we look at method overriding, we're looking at this one and we're looking at this one. Notice these two methods, nearly everything is the same. Both the name and the parameter list are the same now, right? So the method signature, the entire method signature is the same, right? The reason why Java still is able to know which one to use, even though they're called the exact same thing, they take in the same exact arguments, is because they're located in different places. So this one is located in the car class, and this one is located in the pickup class. And they're related by this inheritance structure. So Java knows, hey, if you have a pickup truck, I should use the pickups description method. If I have a car instead, I should use the cars description method, right? No ambiguity, no confusion. I know exactly which one to use every single time. So that's why both of these are fine. Even though some things are still the same, even though names are the same, and in some cases the parameter lists are the same, Java is still able to know which one to use. But really want to make sure everyone understands the difference between method overloading versus method overriding. And this brings us to the homework, actually. So if I go back to the slides and go to the end with the homework for this week is kind of open-ended again, like last week's. And I want just to practice this inheritance structure that I covered this week by creating two different classes. And one is a parent class, one will be a child class that extends the parent. And there's just a couple of requirements. The child class should have an extra field and an extra method. You're going to define new things in the child class that do not exist in the parent class. And then you should do one example of method overloading. So take a method in your parent class and actually I wrote this wrong, method overriding, not overloading, overriding. So take a method in your parent class and make a new version of it in the child class. And then just so that you're not just defining classes and so that you're actually testing it, I want you to create another file or put somewhere where you're like creating an object of the parent class, creating an object of the child class, and then just using some of the methods that you've written. To make your life easier, if you did the homework for this week, then, or last week, I guess, if you did the homework for last week where you wrote your own custom class, you can use that as a starting point. You can use that as the parent class. If you didn't do the homework for this week, like I said, I've included my version of the car class to Google Classroom along with these slides. So you can download that one and have that one as your starting class. And I actually gave a hint of if you're using the car class to start out with, you can do something like this. I said you could create like a convertible class that extends the car class. And maybe you have a field that's like whether the top of the convertible is down or up. And you have a new method that switches between the two states. And then you have method overriding, just like this, by changing the description to add a little bit of information on whether the top of the car is retracted or not. That's just one example of what you could do with this week's homework. That's all I had to teach for this week, and I know I'm nearly at the end, but before you go, I do have one announcement for next week, as well as the last class. I will be starting school next week, and because of that, I actually have a little bit of a time conflict with this class on Thursdays. And I was wondering if you guys would be available for like a later class. So taking this 6 to 7 class and moving it back a couple hours to 8 to 9 o'clock. I was wondering if you guys would still be available. Okay, so see, Christopher, you said you can't. Alan says it can. So I want to get everyone as available as can. 7:15 to 8:45. Ooh. So there's a couple options. We can move it back Thursday, but I see some conflicts. What about on Friday? Whether it's 6 to 7, the same time, but just a different day, or we can also do different time, different day. Would people be available? Okay. So I think we'll have to work through this. I might create like a survey on Google Classroom for people to fill out so we can find a good time. I'm really sorry that this came up. To be honest, I wasn't aware of this until recently. But it just is for the last 2 weeks. I have a little bit of conflict at the beginning of this time period. Okay. Yeah, I think I will make a post on Google Classroom with kind of a survey to see when people are available, and we'll work from there, I guess.
Yeah. So thank you, Jack.